Calculus!
All right, so this is solutions to self-check 9.3. Let's go ahead and just work through this problem as if we just saw it for the first time. So find the average acceleration between 0 and 1, or 0 and 80. This is going to be 1 over 80 minus 0, which is just 1 over 80. Integral of all this stuff. Am I doing this right? That's the average velocity. Ooh, I don't even know if I'm doing this correct. That's correct. Yeah, you want to use a secant line. So if you're doing a secant line, then you're doing, what are they calling? They're calling it V. So V of 80 minus V of 0 all over 80 minus 0. And that's where the 80 minus 0 came over here. But since we can't do an integral, since we don't have an actual function, we have to use our secant line approximation. And V of 80 is 49. V of 0 is 5. And 80 on the bottom. So I get 44 over 80. And again, in my class, you need to simplify this. On the AP test, leave it as 44 over 80. Obviously, I can divide by 4, and I get 11 over 20. So used to it. Yeah, okay. How many points do you get for that? 1 point for the answer. So you just got 1 point. Do units eventually count on the solution guide? Let's see. Yes, they do. Down here it says units in A and B. And it does say in the instructions, indicate units of measure at the very end. And if we scroll up, we can see that our table was in feet per second. So average acceleration. So acceleration is feet per second. And if I find the average of that, it's still an average of an acceleration, so we're still talking about acceleration. So it should still be feet per second. So this would
count as 2 points?
Well, I guess if you want to do, I think the best way to do it is just the way that the AP graders do it, which is do units at the very end, but it's feet per second squared. If we're still talking about acceleration, average acceleration, then our units are going to be whatever they gave us, acceleration. Did we get the units okay on this one?
Yeah.
Cool. Rochelle, yeah? No? What'd you put, Rochelle?
I did put feet per second.
Darn, okay. B, using correct units, explain the meaning of this. So we say that that means what?
Average value of t in feet from 10 to 70 seconds.
Ooh, careful. So it's not average value. Average value is going to have a number out in front of this like 1 over 80. If you see a fraction up front, that would be an average.
How about total distance in feet traveled from 10 to 70 seconds?
There it is, yeah. Oh, don't hate it. It is total distance. So integral means you're going backwards. So if I have velocity, going backwards from velocity is just position. So it's the total position change or total distance traveled. Either one of those is fine. I'm going to say total distance traveled. And it's from traveled in, what are our units? Feet. In feet.
Wait, so this traveled in feet per second? Because that's how it's said in the
So distance is just measured in feet.
Oh, okay.
Yeah, so the antiderivative of velocity is just position is in feet. And then from our bounds were from 10 and 70, and that was in seconds from 10 to 70 seconds. Okay, how many points do we get for that one? And I can't see because of the way that the projector is. I try to make the projector slightly higher so people in the back of my other classes could see, but it makes it so I can't click on the tabs correctly. All right, so you get 1 point for the explanation, 1 point if we, oh, we haven't done Riemann sum yet. So we just got 1 point right now for that explanation. Now we actually have to use the midpoint Riemann sum. Again, midpoint Riemann sum means if I come up here to the table, yikes, come up here to the table, and I'm going between 10 and 70, that means my first interval is going to be 10 to 30, and my midpoint is 22. Then I'm going to go from 30 to 50 with a midpoint of 35, and then finally from 50 to 70 with a midpoint of 44. So those are all the values I'm going to be using. So far, so good? All right. And when I do that, I get 2,020 feet. Should I show the work for that? You want to see how to do it?
No.
You got 2,020?
Dang it! I was scared that I was supposed to put like the fraction.
Oh, like the fraction out front? You only do the fraction out front if they give you the fraction out front. Or if they ask for an average without giving you any symbolic notation. Because they gave us the symbolic notation, just literally do what it says. If there's no fraction out front, don't do a fraction out front. But normally, each of these gaps here between 10 and 30 is a gap of 20, another gap of 20, another gap of 20. So really, I could factor out a 20, and I could say that the answer here is 20 times the quantity, and then I just add 22 plus 35 plus 44. 22 plus 35 plus 44. And that would be the answer, which is 2020.
If I just have the 20 times by whatever number is that, does that still count?
Say again?
So go to the answer sheet real quick.
Yep. Where's my mouse?
So what does it mean by uses B20, B40, B60?
It just means that you use these values 22, 35, and 44.
So if I have those values,
You get a point. Yep. All right, so you get 1 point if you use all three of those values, and you get 1 point if you get the actual answer, 2020. And again, you do need units because it does say in here, indicate, or does it not say that? Let's read. Yeah, you do need units in B, even though it doesn't really say it, does it? Oh, it does say it right at the beginning. Use correct units. So we do need to say that that is the total number. This equals 2020 and then feet because it asks for units. So far, so good? All right, on to part C. All right, rocket B has that upward acceleration. So this is the second rocket. And the initial velocity is 2 feet per second. Which of the two rockets is traveling faster at time equals 80? All right, so this is going to be some manual math. Again, this is a start plus change because in order to find traveling faster, we're talking about velocity. In order to find velocity from acceleration, which is what it's giving us, we have to go backwards, which means we're taking the integral. We have an initial velocity of 2. So my start, and I'm talking about rocket B in this case, my start and then plus change equals end. So my start is 2. My change is the integral between 0 and 80. And it's going to be this function 3 divided by, or I guess I can simplify this already because we know that we don't like fractions. We don't like square roots in this class. So this is going to be 3 times t plus 1 all to the power of negative 1/2. So I need to take the antiderivative. That means this gets added to 1. So this is going to turn into 1/2, divide down. So it's going to be 6 times t plus 1 all to the 1/2. And that's going to be evaluation bar between 0 and 80. When I plug in, this is supposed to be to the power of 1/2. It's kind of confusing there. But it's really going to be the square root of all this. So 6 square root of t plus 1. 80 plus 1 is 81. Square root of 81, 9. So 9 times 6 is 54. And then when I plug in 0, 0 plus 1 is 1. Square root of 1 is 1. 1 times 6 is 6. 54 minus 6 is our final answer. Well, not our final answer, but what rocket B's velocity. 54 minus 6 is 48.
I need that too.
Yeah.
The velocity isn't 48. We need to add that 2.
Ah, you're right. That was just the change. So this thing that we just found, 48, represents this integral right here. So yeah, we do need to add the 2. So our final velocity, our end value should be 50. Okay, from there we need to compare that to time equals 80 of our table. So at time equals 80 in the table, it says it has a velocity of 49. So which one is bigger, 49 or 50? 49
Oh, wait.
is, we're joking, it is 50. Yes, so rocket A has 49, rocket B has velocity 50, so the correct answer is rocket B.
Wait, hold on. So it goes faster. Isn't 50 faster?
Yep, B, 50, faster. Yep, rocket B is faster.
Oh, sorry. I see that.
All right, how to score yourself. Scoring guide for 9.3, part C. You get 1 point if you got 6 square root of t plus 1. So that came from right here. if you got the antiderivative, if you were able to correctly get the antiderivative, 1 point. If you didn't forget your constant of integration, this is the start value. So if you added 2, if you wrote 2 anywhere in there, give yourself 1 point. We wrote our 2 at the very beginning, so that's our 1 point. If you, wait, constant of integration, how's that different from the initial condition? Because initial condition was a +2. Constant of integration, we know, I think you get that 2 points if you wrote +2, literally, because constant of integration, you need to find that, and you know that that is 2. And then finally, you need to compare them and come to a conclusion. So if you came to the conclusion that rocket B is faster, give yourself 1 point. So literally by writing +2 in terms of the AP graders' eyes, that gave us 2 points. All right, and total points out of 9 at the top, where it says correct. How many out of 9 did you get correct? So, chunk.
Oh, wait, there's the units too.
Oh yeah, don't forget your units. Like units, if you got units correct in A and B, you give yourself 1 point.
Are you sure that 2 plus gives us 2 points?
Yes.
'Cause, like, what if they mean something else?
I'm pretty sure you get the 2 points. Yeah. All right. How many points did you get, Ben?
9.
Oh man.
I'll stay quiet.
Stay quiet. Did you get more than 1?
Yeah.
That's good. Did you get more than 3?
No.
Did you get 3?
That just.
3 is what you need for passing.
No, I got 2.
You got 2? Okay, you're almost there. And again, these are just practices. All right.
It's crazy how I added that fraction.
All right, so now we're on 9.4. Now we're talking about a plane. So midpoint Riemann sum, 4 intervals, 0 to 40. So again, you're going to be, I guess I should show the answer and see if it's worth going over. So that is the wrong solution guide. Let's get rid of you. We're on solution guide 9.4. 229. Okay, apparently we're going to go through it. So the way that we do this is midpoint. We use this point with this height. The distance between 0 and 10 is 10, and then the height is 9.2. Notice that the distance between all of them is going to be 10 because I'm going to use this point, and this point. All of these have a distance of 10. So I'm going to actually factor that 10 out instead of keep multiplying by 10 over and over again. The heights that I'm going to be using are these guys. So what essentially I'm saying is that the integral between 0 and 40 of velocity with respect to t dt, that is approximated by our midpoint Riemann sum, which is 10 times the quantity of all of those heights added up. 9.2 plus 7.0 plus 2.4 plus 4.3. So far so good. And then we have to do that math. So is there a quick way of doing this? So 4.3 and 2.4, that's going to be 6.7. That's going to be 15.9. That's going to be 22.9, 229. 229. Does it say anything about units? Yeah, using correct units. So our units here, we're counting up total miles. So integral velocity should go backwards to position, which makes sense. So our units here, 229 miles. Questions?
Okay, so I did without taking out the 10, I just did everything. So 10 times 9.2 equals 92.
Yep.
10.7 equals 70.
Yep.
10 times 2.4 equals 24.
And 43. Yep.
43. 92 plus 70
Yep.
is 162.
Yep.
And 162 plus 24 is
186.
26.
186.
186?
Yeah.
I'll just show you
Or did I mess up already?
because what I did here, like, I lined them all up. And then 7 plus 4 plus 3 equals 4. Because 4 plus
Yep.
equals 7. 7 plus 7 equals 14.
Wait, 97. Where did 97 come from?
Oh, that's it. I found 97.
Okay. Again, for scoring for this guy, it looks like 1 point. If you just used those values, 9.2, 7.0, 2.4, 4.3, you get a point just by using those. You get 1 point if you say 229, and it also asks for meaning, which I have yet to do. So explain the meaning of this, and that is the total distance in miles between 0 and 40 minutes. I can write that out if you want, but it's, again, it's a total distance traveled in miles between 0 and 40 minutes. You get 1 point for the explanation. Any questions on A before we move on to B? All right, on to part B. All right, so based on the values in the table, what is the smallest number of instances at which the acceleration could be 0? So acceleration is the derivative or the slope of velocity. So if I were to graph these points, graph them in my head, where could you have a turnaround? Where could you go up and then all of a sudden come back down? So where do you start switching? So from 7.0 to 9.2, I'm going up. This is a positive value, so I'm going up. From 9.2 to 9.5, I'm still going positive. From 9.5 to 7.0, I have now suddenly gone negative. 7.0 to 4.5, I've gone negative. 4.5 to 2.4, I've gone negative. From 2.4 to 2.4, I haven't done anything, so no change here. And then I start going up again. So I'm going up, and then all of a sudden I start going down, then all of a sudden I start going up. The question is, what is the smallest number where the acceleration of the plane could be 0? Do you see the 2 points that have to be 0? That you have to have a 0 somewhere in between 10 and 15, right? Because you're going up, and then all of a sudden now we're going down. So between 10 and 15, somewhere in that interval, you have the velocity equal to 0. And it looks like 25 and 30. 25 and 30. Those are the two intervals where you have to have the acceleration equal to 0. And by what theorem is that guaranteed? What theorem guarantees slopes? It's one of the three theorems that we know.
Is it the y minus something equals x minus something?
That's just an equation. So we have EVT, MVT, IVT. It's one of those three. What of those theorems guarantees slope?
Intermediate value theorem.
Intermediate value theorem guarantees heights. It's a mean value theorem. So this is true by MVT. I'm not quite clear on if you have to say by MVT, but I'm pretty sure we should be used to saying that, because if it says justify your answer, you have to be using a theorem to justify your answer. So my answer is going to say by MVT, two instances, I guess is the word that they're using, instances of 0 acceleration. And it's on those intervals, on those two intervals right here. And technically, to apply mean value theorem, we need to actually set our derivative equal to 0. So technically, we should be using, we have to find two numbers that are the same. 9.5 isn't the same as anything else, so we can't use 9.5. 9.2, that's not the same as any of them. We can't use that. Look at this. 7.0 and 7.0. Mean value theorem states that you need to take the difference of the y's, and then that's going to be your numerator. So you'd say mean value theorem is where f prime of c is equal to some value where it's going to be f of b minus f of a all over b minus a. Well, now f of b and f of a, the heights that we're looking for, or these velocities, have to be the same, because now f of b minus f of a is 0, which is the same thing as saying acceleration is 0. So if you're actually using mean value theorem, you probably want to use, instead of the interval between 10 and 15, you want to use the interval of 0 to 15. And 25 and 30. 25 and 30 both have heights of 2.4. So those are the correct intervals to use, 0 and 15 and 25 and 30. Somewhere on those two intervals, it's guaranteed by mean value theorem. So far, so good? How to score yourself? See, it even used 0 to 15 as well. So if you get those two instances, if you said two instances, you get 1 point. If you said mean value theorem and have those two intervals, that's another point. How many of us got that one? That was a hard one.
So I got 1 point for those two.
Good. Okay, Rochelle? Okay. And then we're on to part C. So we have a new function. It's defined by that lovely trig function. It's used to model the velocity. we need to find the acceleration at t equals 23. So if that function represents velocity, it says it's velocity right here, then what do I have to do in order to get to acceleration?
Take the derivative.
Take the derivative. So that means velocity is going to be equal to f prime of t. If you actually write this out, you might get a point. I actually haven't looked at the answer key yet, but usually as a force of habit, just say, I'm looking for velocity. I'm going to be taking the derivative. Let's do that. Just showing your work. So taking the derivative. Derivative of 6. Nothing. Yeah, it's a constant. Derivative of cosine of t over 10. Derivative of cosine. Negative sign.
And then you have to divide the whole thing by 10.
Yep. So that was doubter. Don't forget dinner. Dinner takes the derivative of the inner. Derivative of t over 10 is 1/10. So divide that all by 10, or multiply it by 1/10. Now I have to add that to the next part. 3 sine of all of that. So I'll leave the 3 out front. Derivative of sine. Cosine of 7t over 40. And dinner is 7 over 40. So 7 times 3 over 40 of that. And now I need to plug in 23. Because it's actually saying evaluate at 23. So that means t is 23. Sine of...
You would need a calculator to get that, unless you're just going to leave it as sine.
Yeah, that's weird. Because this is problem number... If I go to the answer key... This is question number 3. You don't get a calculator, but it is form B. Form B is the harder one. So how did they do it? What? How did they get that without a calculator? I am 100% sure you are not allowed to use a calculator for this.
How did they get that?
That's 23 divided by 10.
I think for this one, because we don't have a calculator, you'd go like this.
Is it possible that...
You can't simplify it, is the answer. You just leave it as sine of something. So the answer here is going to be, I'm going to do, yeah, we'll just stay with the negative. So negative 1/10 sine of 2.3 plus 21 over 40 cosine of, we're plugging in 23, oh gosh, 23 times 7, 23 times 7,
161.
Yeah.
161. 61 over 40. That's the answer.
Will they still let us count that?
Yep. I'll count it in my class. They'll count it as well. You don't have a calculator. This is number 3. You only have a calculator on number 1 and 2. That's your answer. That's as far as you can go. All right.
How many questions do we have? Or form? In each form?
So you're only doing Form A, unless you have to retake it for whatever reason. You remember watching Stand and Deliver?
Form A is pretty easy, but form B is the harder.
Yeah, to discourage cheating, like, oh, or to discourage you kicking back and having more time to study. So in terms of just the free response, though, there are 6 questions. The latter 4, no calculator. First 2, you do get a calculator. Did that answer the question? All right. And then D, according to the model, what is the average velocity? Oh, okay. So now I'm using this word average. Average means what is going to be changing. What do I add?
Oh, you added 23? But it's saying to. That's given in part C,
So
or is it just 0?
I guess I'm just asking the question wrong, but so we have right here, this represents what?
Acceleration.
The acceleration. I don't know why I wrote velocity there. It should be acceleration, yeah. So this represents acceleration. So what do I do to acceleration in order to get average velocity?
Take the antiderivative.
Antiderivative, and in order to make an average, what else do I have out front out here?
1/40.
Yes. 1 over 40 minus 0, which is 40. 1/40th of the integral of this function. So I'm just going to say a of t, dt. And literally, if they want you to rewrite it again, you would write all of this stuff divided by 40. So I guess I'm not going to do that. I wonder if I can just use technology to...
Wait, but that's the derivative. This is the
Oh, this is antiderivative. So if we go backwards... Oh, if we go backwards, then we already have it, right? We go backwards, we're left here.
No, because we have to go backwards from velocity, not from acceleration. To get the average, we have to go backwards from velocity.
But that is.
No, so you go backwards from acceleration to get to velocity. So average velocity...
But that doesn't get you the average. Because, so taking the antiderivative,
Oh, you're right.
it gets you the average, or
Nah.
it gets you the total change in velocity.
Yeah. I don't know what I was thinking there. Yeah, because essentially what you want to do is, so if we just think about this in the real world, if I am going at a certain speed, if I want to calculate my total speed, I need to calculate all of the distance that I've gone and then divide it by the total time. That would be my average velocity. So I need to go to distance. Antiderivative of what will give you distance? And Ben has already told us velocity. Does that make sense? Rochelle nods her head. So this needs to be VT. So now we need to go backwards from here. So now we need to do an antiderivative. So instead of saying VT, we actually going to find that. So it's going to be 1/40th. And again, this is all going to be left basically unevaluated. 1/40th of all of that stuff. Lovely. Okay, so antiderivative of 6 is 6t. Antiderivative of cosine t over 10. How do I do that?
Would that be negative sign?
Just be
Or no,
sine.
it'd be just be sign.
Yep. So this is a t, and then it's going to be plus sine of t over 10. But there's a problem with that because that's not the antiderivative. We forgot.
Dinner.
Kind of. It's the reverse dinner, which is called taxman. You didn't pay the taxman. Dinner here was 1/10, which means we need to use u substitution or taxman. When you use taxman, do we want a quick review, or do you know that the answer is just going to be 10 sine of that? Quick review, yes, no, maybe so? Rochelle? You don't need a review? All right, so you know it's 10 sine of t over 10. And then I need to add this to, okay, antiderivative of sine.
Negative cosine.
Yep, so it's going to be negative 3, leave some room, cosine of 7t over 40, 7t over 40. Again, taxman means I'm going to multiply this by, out front by,
7 over 40.
careful,
40 over 7.
40 over 7. Exactly. The general idea, if you want to kind of avoid taxman, is when I take the derivative, chain rule says I'm going to multiply by 7/40. To undo multiplying by 7/40, I have to divide by 7/40. Keep it, change it, flip it means I'm really flipping this to say 47ths and multiplying it.
Why is it a negative 3?
-3 because antiderivative of sine is a negative cosine. Good question.
Doesn't it stay the same?
So antiderivative, so anti-same, it starts with an S. So anti-same is change, so change the sign.
Do we have to add the constant of integration? Plus c?
Yes, you do. Because, oh wait, so this is technically
Definite integral.
it's a definite integral, so you shouldn't theoretically need to.
Alright, so we're good.
And don't forget to finish your bracket because all of that was multiplied by 1/40 because it was an average value. Let's see how they say it on their end.
We're probably going to get the exact value again. Yeah.
How? Okay, well, that's as much as we can do. So, because we do have bounds, just go like this. To get your final answer, this is going to be evaluated between 0 and 40. You can't take, you don't know what sine of 4 is. You don't know what cosine of 7 is, so you can't plug in those values. You know what sine and cosine of 0 is, but that doesn't really help. That answer will get you full points on the AP test. That answer will give you, it might not give you full points because you usually want to actually sub in 40 and 0. So you might need to write 40, 40, and then this whole thing again, minus 0, 0. Yeah, that was really difficult. Yeah, don't take Form B. Take Form A. All right, I'll put the answer keys online so you can score yourself and look at them again. You guys are officially dismissed.